Okay, so we can start now. So as I said, we're going to go through utility functions in this workshop. I don't think it's going to be super long because it's not that like difficult to go through. So just a reminder, these are the symbols that we use to show like preference. It's quite similar to like regular math notation that we do. Like I said last time, it just kind of looks like it's in cursive, like it just looks a little fancier. But there's three ways to denote like preferences. So it's either it's strictly preferred, like X is strictly preferred to Y, X and Y are equally preferred. So it's kind of indifferent, like you don't care about which good, like you don't prefer one good more than the other. And the third way is that X is at least as preferred to Y, if not more. So that's kind of weakly preferred. So it's pretty similar when we talk about utility functions and when we like do the symbols, except now you have a U at the start before the X. So as you can see here, it's just X is strictly preferred to Y, but here it would be the utility of X is preferred to the utility of Y. So yeah, this is basically it. You can do it to explain like preference for two bundles. And you can also do it to kind of like just show. So the only difference is that when it's kind of indifferent, when X and when a person is indifferent to the goods X or Y, you just say that the utility that they get from X and the utility they get from Y is the same. So you just use the equal to sign. So yeah, it's pretty straightforward. Moving on, so utility is an ordinal concept. So for example, if the utility you gain from X is equal to 4 and the utility you gain from Y is equal to 2, then X is strictly preferred to Y. But even though 4 and 2 here are referred to as utility levels, it doesn't mean that X is preferred twice as much as Y. So like we don't kind of know the intensity about the like preferences and utility. It's just that we know that it's preferred, like X is preferred over Y, not how much more. So you can't kind of like quantify it, and I don't think you do. Like I don't remember quantifying it last year, so it's just something that you should keep in mind. So when can a preference relation be represented by a utility function? So a preference relation can be represented by a continuous utility function U if the relation is 1, complete, 2, reflexive, 3, transitive, and 4, continuous. So these are 4 assumptions that we talked about last time. And I'm just putting the slide that I used last time up again. So this was the slide. I'm just going to give you a minute to look at it. It's not too complicated, but yeah, like I'm pretty sure last year we just assumed that for any like preferences you could have like utility functions because I don't think it was that complicated, but just in case like you wanted to know, these are the 4 assumptions that you need to keep in mind when thinking about like preferences and utility. So there are 2 properties, only 2 properties that I'm actually gonna like talk about because these are the ones that tend to come up in exams. Like they'll tell you to kind of like, they might just ask you, oh, is this bundle like convex or does it have like monotonicity? Like does it show it? So I'm just gonna talk about convexity and monotonicity. So I'm talking about convexity first, and convexity basically says that the agent prefers averages to extremes. So if the agent is indifferent between X and Y, then he or she prefers the average, which is basically denoted by this. So preferences are convex if whenever the utility of X is greater than or equal to the utility of Y. So basically, just think of it this way. If there's 2 goods, if good A is like good X, sorry, is like apples, and good B is like good Y is bananas. If convexity exists between those 2 goods, you would just say that you prefer to have a mix of like apples and bananas. So you kind of prefer to have like an average than to have only bananas or only apples. That's basically all it means to have convexity between 2 goods. It's just something that you should keep in mind because they will probably ask you about it. And if you haven't gotten your problem set 2, I'm pretty sure that this question comes up in the second problem set if the professor is not changing them. The second property is monotonicity. So preferences are monotone, if more of any good makes the agent strictly better off. So this assumption is useful because it implies that sorry, I have typos in this, curves are thin and downward sloping. So this is basically just some notation that you should keep in mind. Again, I will put this PowerPoint up so you can go through it again like later if you want to, but it's pretty basic stuff that I'm talking about. So most of this, as I said, is kind of just symbols and things you should know. Utility functions are like pretty similar to the preferences stuff that we talked about last time. So utility function and indifference curves. Indifference curves through a fixed bundle X can be written as this. So usually we use curly like brackets like this and this to talk about utilities. And this is just an example of a utility function when the utility you get from good X and good Y is the same, which basically means that they're perfect substitutes. So now I'm gonna just talk, I'm gonna delete the slide actually. I'm gonna talk about some, like just show you guys some graphs. So perfect substitutes, this is actually like this pretty similar to the graph that we saw last time when talking about perfect substitutes. We just said that they both are just downward sloping and they're parallel. And we also, I'm pretty sure we talked about marginal utility and the marginal rate of substitution last time, which is just sorry, I'm just losing my words, which is just the slope. So this is how you would calculate the marginal utility of X over the marginal utility of Y, which gives you the marginal rate of substitution. So in this case, you would just kind of do like your basic derivative to get the answer. But I've put all of this up here just so that you guys can like go through it again later. And perfect complements is also the same thing. Usually the utility function for perfect complements would be like a minimum function. So as you can see here, the utility of X and Y is equal to the minimum function of X and Y. And the budget constraint is the same as we saw last time, where M is equal to the income and PX and PY are the prices of good X and good Y respectively. So this is the exact same graph that we saw last time, like the indifference curve graph, where it's kind of like an L shaped, like it's like straight edges. So yeah. And this is something that you should just keep in mind. It's just marginal utility when only consuming one good. So for example, X is the quantity of the good and UX is the utility function. The marginal utility at quantity X is the additional utility a consumer derives by consuming an additional unit of the good. If the good is infinitely divisible and U is differentiable, we can use calculus to find the marginal utility, which is basically you differentiate X in respect. You differentiate the function, but in respect to X. This is basically when I put it over here. This is kind of all you need to know about like utility functions really. Like next week is when I'm talking about optimality, and that's when it kind of starts to get a little bit harder. So like this workshop is really, really short. But if you guys have any questions, just let me know. But like, yeah, it's pretty simple, pretty straightforward. So does anyone have any questions, or is there something that people want me to go through? Slides used in workshop number 1. Yeah, do you want to look at the slides right now? I posted the slides for the first workshop under the Facebook event. But if you want me to email them to you, just let me know in the chat, like put your email down and let me know you want the slides. No, like I'm gonna do practice problems next time because I just want to save that for the last like workshop because I don't really want to go through them today. So the slides are posted under the Facebook event for the first one, and I'll do the same one for the second thing. But does anyone have any other questions?
have a question.
Yeah.
Would you be able to elaborate a bit more on the perfect complement slide with the minimum of x and y? Like, I'm
Okay.
not sure if you understand.
Yeah. So we can go back to perfect complements. So basically, I talked about this last time, perfect complements, like the best example to give is to talk about shoes. So like a left shoe and a right shoe are perfect complements. So for example, if you have one left shoe, you just need one right shoe. Like getting more of it doesn't give you more like utility, like it doesn't help you in any way. So that's why you have a minimum function. You just need the minimum of like one of both the goods. Like if you have two left shoes and two right shoes, that's fine, but getting more of like one good and not getting more of the other doesn't make any sense. So for example, if the utility function was if x is a left shoe and y is a right shoe, minimum of, like if it says minimum 1 comma 2, you would just go with the 1. So you would just say that like I get the same utility when I have one left shoe and one right shoe, and when I have one left shoe and two right shoes, if that makes any sense.
Yeah, okay, got it. Thanks.
Yeah, okay. Let me just go to the chat. Okay, yeah, I can definitely email the slides. If you weren't here when I like started talking, if you want access to past midterms and past finals, can you also drop your thing into the like your email into the chat, and I'll just email it to you. But yeah, like super short workshop because it wasn't that like complicated. But if there's specific things that you guys want me to go through in the next workshop, can you write it down in the chat as well so I can kind of make a note and just go through that.
I have a question.
Uh-huh.
I don't really understand the difference between strong monotonicity and normal monotonicity.
Okay, yeah. Just give me a sec. To be quite honest, I don't have anything about that in the like PowerPoint. Who asked me that question? Can you just say your name?
Yeah, Luis.
Okay, can I send you an email after this is over and just like go through it then? Because I feel like I just need like a
yeah,
little.
that's right.
Yeah, okay. I'm just gonna make a note really quick so I don't forget. Give me a second. Strong. Okay, does anyone have any other questions? I'm just gonna stop recording.